Hi everyone, welcome back to our 2025 user group meeting. My name's David and I'm from the support team here at Vectric, and today I wanted to take a look at how we can use gadgets and job efficiency tools within the software to create these modular storage solutions. For those of you that aren't already aware, gadgets are small applications which add functionality to VCarve Pro, Cut2D Pro and Aspire. They're not available for the desktop versions of our software, but if you are a desktop user, then just be aware that you can still follow along with this. It's just the automated toolpath generation and vector drawing processes would have to be completed manually. First of all, we'll just take a look at the gadgets that we're going to be using for this project, which will be the Keyhole generator and the box creator gadget. Now the Keyhole generator is included as standard with the installation of the software, but with the box creator gadget, we just need to download that from the gadgets page on our website. So first of all, we'll go to vectric.com, and under the community header, we'll click on gadgets. And we'll see that they're categorized into different areas of functionality. So we've got drawing, modeling, toolpaths and job file management. So because the box creator actually creates the toolpathing for the box as well, it's going to be under the toolpaths category. And we'll see that it's actually the first in the list under here. So we'll click on download gadget and that'll place the installer into your downloads folder. And then back in the software, we go to gadgets in the menu bar, install gadget and select that from the list. We'll see a license agreement and a message saying that the gadget is successfully installed and it's available to use from the gadgets menu. So now that we've installed the gadget, we'll get started with setting up our file. We'll start now by creating a new file. We want a single-sided job with width of 1220 mil and a height of 2440, and that's actually an 8 by 4 foot sheet. We're using 9mm ply, so 9mm, Z0 position from the material surface, XY datum in the lower left and very high modelling resolution. And we'll click OK to set up our first sheet. So we're going to go through and just arrange and organise our sheets so that we can better visualise the different components of our final project, because it is a multi-material project. So first off, we're going to call sheet 1 ply caddy, and we're going to add a new sheet, and this is going to be another sheet of 8 by 4 ply. This is mostly in order to assist us in creating the backing, the perforated backing board, because I'm going to want to use the XY datum position to help with the whole array. But for now, we'll call this ply perf. And we also need to set up a sheet for our shadow foam. So obviously this has got different dimensions. And just to note, if you try and do this from the file operations, when you've got multi sheets, you'll see that if they're all the same size, you can actually still use the job setup dimensions, but that will apply to all sheets. So we don't want to do that in this case. You need to go to the Sheets tab, click Add New, and we'll call this Foam. And then we can click on Edit, and we're going to want 600mm by 420, and the thickness is 50mm. So this is actually made up of 5 10mm layers that you can peel away and reveal the depth of the pocket that you require. And we'll keep that all the same. So there we go, with our material setup, we'll now start by looking to create the initial box that's going to form the outline of our caddy. So we can now use the box creator gadget. So we'll go to gadgets, box creator, and in the form we'll see various parameters, which include the overall dimensions and the joint allowances. So we'll just work through. We're going to want a box with the width of 500, depth of 300, and the height is something to be aware of with the box creator. So if you choose to deselect mate lid, so you can make a complete enclosed box, but in our case we don't want to. If you select that, it's still going to create the dimensions as if a lid is expected. So half the material thickness is going to be added onto the top. So I want a height of 250 mil. So that means with 9 mil material, I need to put 254.5. The joint width, we're going to change to 50 mil because it's a larger dimension, and the allowance is going to be 0.07 millimeters. That doesn't seem like a lot, but it is additive, so it's added onto all surfaces, and the two corresponding parts will add up to a total gap of 0.14. We want square tabs. We don't need to worry about the lid type, and we can click OK, and we'll see that the box creator gadget has auto-arranged the parts at the bottom of the sheet for us there. We can change the placement of this, but I think for the use of the material, that's fairly good. So all we need to do now is just switch over to the toolpaths tab, and we'll just work through the form and just review some things. So for my purposes, I'm going to want to cut through very slightly past the total material thickness just to account for any inconsistencies. We'll click on edit, and we can see that the feed and plunge rate has been pulled through from the saved tool data. So in this case, I'm actually going to be using a compression bit. So obviously cutting ply, I want to be down cutting in the top layers and then up cutting at the bottom, so everything's held together and there's no tear out. So to do that, we just need to make sure that the first pass is actually above the down cut portion of the bit. So I'll clear all passes, and I'm going to manually add in a first pass of 7.25 mil. So I'll just click apply and OK, and we'll see that that's been changed to 2 passes in total. You'll see that the box creator gadget actually produces 2 sets of vectors. So the external one you can see here is actually the path of the tool, and this is where the allowance is going to be applied between the edge, the external edge of the expected box sides and the vector shape. So you can check that just as a sanity check by switching on the 2D view and switching to the solid mode, and you can actually see in purple here, well, purpley blue, the overcut distance. So this is the allowance, and we can go in and measure this just to make sure that that's been applied. And you can see 0.07 mil. That's a good thing to be aware of with the box creator gadget actually, because the imported vectors and toolpaths that are created are auto-arranged. Any changes in the position or the actual tool type, not the settings but the actual tool geometry, will mean that it's recalculated circumventing the gadget. So you just need to make sure that the same allowances have been applied, and using the 2D solid view is a really good way of doing that. Now we've done that, we can take a look at the machine direction. So automatically it'll be set to a climb cut. In our testing with the allowances for the box creator, the conventional cutting direction does actually lead to a larger gap and a looser fit. So I'd always recommend, and the box creator gadget does automatically default to climb. We're going to have a look at the tabs, because this is quite hefty material, so we're going to need a sufficient hold down. And whilst it does do a good job at auto arranging the tab locations, we do just need to go through and make sure that they're in the optimum position. So I'll just run through, change these around. So we've got a layout that we're happy with. We've got no tabs on the corners, so that's great. And we'll check the thickness. So it's 1/4 of a mil as standard, or if you're in an imperial units job, it'll be 0.25 inches. A length of 50 mil. I'm going to add ramps 100 mil, and we'll call this caddy box cutout. And click calculate. So that's our first toolpath setup. So we'll set everything else up first and get a full layout, and then we can preview the toolpaths. Right, the next thing that we're going to do is just to organise our job, is to take a look at the layers that were auto-created by the box creator. Now, another thing to be aware of with the box creator gadget, if you do need to make multiple box layouts within the same job, it is actually going to use the same layer names each time. So if you went to calculate a subsequent box, it's actually going to pick up the vectors placed on the same layer, so the cutout and box layer. So it's always recommended to just rename this, and that means that any subsequent uses of the box creator will just apply to the required geometry. So we'll call that caddy box and caddy cutout. And just for visualization purposes, I'm just going to change the layer colors. Might as well use this because we're going to have a few different layouts going on the same sheet, just to make the most of the material workspace. Okay, so now we've got the outline for our box. We're just going to need to make the handle that's going to double up as a separator and hold everything together, slot together. So first of all, we're going to the Create Rectangle tool. So now we're going to draw a rectangle with a width of 491mm, a height of 245.5, and we can click with the anchor point in the centre to place that just above our layout there. So the way this is actually going to work as a slot together caddy is this is actually going to sit halfway down the material thickness on all sides. So we are going to need to notch the edges, but first we'll sort out the handle shape. So we'll draw an ellipse with a width of 280mm and a height of 160mm. And with the anchor point in the centre again, we can come over to the existing rectangle, and with the object bound selected, we can pick up the centre line and just place that in the centre there. So now we just need to create this into an external single closed vector shape. And we can do that by using the interactive trim tool. So there's two results from this really. So you can either create individual open vector shapes whilst trimming away the internal part of the vector, or you can rejoin those sections together. So make sure you've got that selected, and then we can just click to trim those away. We can close out the form. So that's the basic shape, but I do want more of a swooped profile to this. So a good way of doing that is using fillets actually. So usually they've got a functional purpose of accounting for the tool diameter, but in this case we can use it as an aesthetic choice. So we'll click on normal fillet, set it to a high 70mm, and we can just click both of these corners just to get a nice flowing profile to the top of that handle. And now we just need to create another ellipse just for the internal handle. So that'll be 140 in width, and that's actually based on a good rule of thumb for a generic human hand of being no less than 120mm wide. And then we can click to place that. So there we go, we've got the outline profile. So we just need to sort these notches that are going to allow the top of the separator there to sit flush to the top of the box. So to do that, we're going to draw a rectangle 4.5mm, so it's a square in this case, and we can use the anchor points in the form to help us place these. So instead of zooming in right on the corner, we can check the corresponding button there and just quickly go around and place those. Now, what I'm going to do is quickly box select these squares, and we'll just group these together, because again, it just avoids us having to zoom in later on. So now I do want to create a single outline including those notches. So I need to subtract those shapes from the existing outline shape. So to do that, we can use the subtract tool under edit objects, and the object that you're subtracting from the outline shape should be selected second. So we've got the notches selected there, and you'll see that that's been applied, and we've now got one complete closed vector shape, including the handle and notches. So now we've set that up, we just need to look at quickly toolpathing this. So just a basic profile toolpath. We're going to use much the same settings as the rest of the boxes. Just make sure that we've got the tab placement set up correctly. Same tool settings, feeds and speeds and everything. So we don't need to worry too much about that. And also just edit the passes. Again, because it's taking that from the existing save tool data. And we're using that compression bit again. And we'll just call this handle cutout. Not like that, we don't. And click calculate. We'll see a warning that we're going to be cutting through the material, which we're aware of. And now we can move on to the next part of our layout, which would be the actual notches, the slots that the notches are going to sit within to make a complete box. So to do that, we're going to again use the draw rectangle tool, and we're actually going to add the allowances in to make a good friction fit into the shape that we're going to be pocketing out, rather than creating the exact material thickness in these rectangles for the slots and then adding the allowance in the toolpath. So there's two ways of doing it really, but this way just means that I'm thinking about it as I'm going along. So for the slots, the first one is going to be 505.956 mil long. So because it's going to be in the horizontal layout, we're going to add that in as the width. So 505.956, and that is just because I've measured it previously. So that's a unnecessarily exact number. And again, just make sure that your anchor point's in the centre if you're going to try and pick up the centre of the shape that you're looking to snap to, because I didn't. So now that we've got that in place, we just need to create the slots that are going to allow the separator panel to sit into the side of the box. So again, very similar process, but this time we want to switch it around. So because these are vertically laid out, we want a width of 9.25 to include that allowance, and a height of 236.5. And we can just come down the anchor point in the middle and just quickly place these, close out the form. I'll just move down and just arrange these so they're in the correct position. And the last thing that we're going to need to do is, as I mentioned with the fillet tool earlier, when you've got sharp corners, sharp internal corners like this, just need to make sure that these are filleted. So going to be using a 1/4 inch end mill. So for the tool radius, just enter 3.175, and we can go around and click to add these dog bone fillets. So we've got dog bone selected, and you'll know that it's available to apply to a corner when you see the tick appear. So we can just left click and close out the form. Right, so now the vectors are drawn up for the slot together caddy. We can now look at toolpath in this. Okay, so we're going to want to set up some pocket toolpaths for this. So I'll go into the pocket toolpath form under operations there, and we're going to select the 3 slots. The cut depth we're going to want to go very slightly past the halfway line, so we'll go for 4.7 mil. Double check over the tool settings. It's exactly the same settings as the box profile. Feeds and speeds are all good. We're going to use the offset strategy, and just remember we need to clear out those passes and set the first pass depth to below that down cut section of the tool. Climb cutting direction. Going to ramp the plunge moves just 10 mil and calculate that. So we can see those have been applied. Just going to go back in and rename those slot pocket. And now we've got the complete layout for the box caddy, we can just lower the preview speed slightly, and we'll just preview that. And we can use the 2D view in version 12.5 of the software to twiddle this as it's previewing and just double check for any potential machining issues. This is looking good. The ramps there have been included, I can see, and the tabs have been left in place. So just check around, make sure there's nothing to interfere with the profiles. And there we go. That's our completed layout for the caddy. So now we do just want to take a look at making the most out of our material, the available material. So I would like to see if I can include some layouts for additional boxes on there. So this is a very similar process to creating the caddy. So we're not going to go through that again today because it's literally just changing the dimensions in the box creator form and just auto arranging, but manually arranging them yourself. So I've actually already done that in this following layout. So as you can see, I've gone through, run the box creator gadget another couple of times. So we've got two more box dimensions of 200 and 100 mil. And I've arrayed those, so you can actually array the auto-generated toolpath from the box creator, and the allowances will be included. So that's our final layout, and you can see that we're using half of our, just over half of the 8x4 sheet there, so we've got a bit of space to use up, and we can have a look at maybe squeezing on the perforated backing board. But for now, we're going to switch over to our ply perf sheet because we're going to need to have an empty workspace so that we can use the datum position in the bottom left-hand corner to help with the array that we're going to create. For now though, we're just going to go over the tooling and materials that we're going to use and just discuss the purposes of the Keyhole gadget and what a Keyhole pocket will actually do for us. So if we just take a look at the tool that we're going to use here, we'll see it's quite an unusual geometry. So we've got two diameters there. So we've got the major and the minor diameter. So the way that this is intended to work is it'll plunge into the material, move along a profile, and then without retracting, move back along the profile to the start point before then retracting. So that leaves you with an undercut. So anything that you place behind the major diameter and push down, as long as it can fit into that channel, will then have material above it and will prevent it then from being removed laterally, so being pulled away. So that's exactly what we want to do, and that will enable us to affix screws to the back of our boxes, which will then slot down. So you can see the way that this tool works. It goes in there into the major diameter, moves along, and the neck will cut the smaller diameter slot back out to the start point and retract. So now we know how that works and exactly what we're looking at with the gadget. We'll jump back into the software and we can get that set up. Okay, so we switch back over to the ply perf sheet, and the first thing that we're going to do is create a rectangle to represent the external dimensions of our backing board. So that's going to be quite large. It's 600 by 900. And we'll click to place that there. And I want to copy the external profile of the handle. So we're going to set up an ellipse in the same way that we did for the caddy. That's going to be 280 by 160 again. I'll just pick up that centre line, place it there, and we can use the interactive trim. Just make sure each time that the rejoin is selected, because otherwise you'll just have to use the join tool to make a complete closed vector shape again. Into the fillet, normal fillets. Oh, and we change that to the tool radius, so need that to be 70. 70mm normal fillet. There we go, on both sides. And now we're going to look at creating the circles that we're going to use as the basis for setting up our keyhole toolpaths. So first off, draw a circle of 10mm, and we'll just place it down there. And we're going to move that to an exact location, so an absolute position of X10 and Y20. Just make sure that anchor position was in the right place actually. No, it wasn't. Wanted that bottom left. X10, Y20. And click apply. And now that's in position, we can then look to use the array copy tool to make an arrayed pattern effectively with an offset included. And this is just going to optimize the space, and it means that you can add in different modular features to the backing board and offset them, so smaller items can sit next to each other. So to do that, we're going to the array copy tool under offset layout, and we're going to want 44 rows in totals and 29 columns. We're going to have a gap for the spacing of 10 in X and Y, and a column displacement of X10. And we'll click copy, and we'll see that that's just been worked out to create a really close fitting, tightly packed in array for this overall outline shape. So we've got coverage up to the edges, but it's not leaving us with cut off half circles, which can happen when you've got a boundary vector selected. Right, so now that we've done that, it's a good opportunity to just switch back over to the Ply Caddy sheet, and we can demonstrate moving over some of these backing pieces for the items that we're actually going to affix to the backing, and we can arrange these and just see if we're using the space wisely, see if we can cut down on the amount of keyhole toolpaths we're cutting. So to do that, we can go select the item and click copy to. We want to copy it to another sheet in this case, so it's the Ply Perf sheet. I will do the same for the other two. Just making sure that I'm actually getting the backing pieces, because it can get quite confusing. Just have to kind of think about it for a second. So now that we've got these in place over the top of the board, we can manually move these around, adjust everything, see if they sit together well. Another thing that you can actually do now you've got the arrayed circles is save the vector file out for this, because this is really handy to actually print out and use as a guide. So once you've cut your boxes, you can actually print that off, make sure it's 1:1 scale obviously, and then use that as a drilling guide to set up manual operations if you're not going to be cutting holes on the machine, on the CNC machine. Okay, so that's all looking good. But I can see here, because I'm only going to be attaching the caddy at the lowest level, so it's within reach. Don't have to reach up too high to place that back on the backing board to get it out of the way and organise the workshop. And we only want the top section really for the smaller items. Don't really want them cluttering eye level. So any fixings and any bric-a-brac will be out of the way. So what I'm going to do to just cut down, because this would end up with quite a number of individual plunge and retract operations. So I'm just going to delete out the section in the center because I'm going to leave that blank so that I can put some modular fixtures like roll holders for spillages in the workshop. It's always handy to have blue roll or the kitchen towel on hand, regardless of the application actually. So now that we've done that, we can delete these out because we don't actually need these on the sheet. We're not going to be toolpathing them. Could just switch the layer off, but just to tidy things up. There we go. Right, the next part of the process is actually going to be using the Keyhole toolpath on this. But because once you've applied that, you can't actually move the toolpaths. We're just going to move the entire layout in so that the profile is it's not going to be off the workspace. It's going to be offset from the XY datum position. So to do that, we'll just go back into Move Selected Objects, go for an absolute position with the anchor point in the lower left-hand corner, and we'll just go for 20 mil in X and Y. And that's just giving us enough of a border to make sure that we're offset from the XY datum position. So all we need to do to run this keyhole operation is select the circles that we're going to use as the basis of the center point and go up to the gadgets in the menu bar, and we'll click on Keyhole Toolpath. And this again, if you remember, this is pre-installed into the pro versions of our software on Aspire, so you don't actually need to go and pull this down from the gadgets page. So in this orientation, we're looking at a portrait top to bottom. So we're going to be hanging items on the wall so that they slot into the external larger diameter and get pulled down via gravity, and their weight to then slot in and prevent being pulled out from the front by that overhanging area of material. So we need to select top to bottom. The depth of the slot, it's usually recommended with the keyhole bits to use the full neck length, but the total cut depth of the tool that I'm using is actually 11 millimeters. So that would be through my material. All that we need to make sure of is that the length of the major diameter, so the larger tip of the tool, is within the material enough so that there's enough of a skin of material over the top overhanging to be strong enough to prevent the items that you're looking to place on the board from tearing out. So I've gone with 8mm for that. Length of the slot is going to accommodate the full a full head of the screws that we're going to be using, so that's 10mm. Entry hole diameter is dictated by the actual tool that you're using, so for me that's 9.525 for the entry hole diameter, the major diameter, and the minor diameter, slot diameter, is 4.7625. So underneath this we've got preview layer name, and this is just going to create an additional layer which is going to include the vectors that trace the outline of the resulting profile that pocket that you're going to see created by the keyhole tool. Because our software can't actually display undercuts in the 3D view, all that you're going to see is a straight slot effectively. So the vector just represents the overall shape that you can expect to see on the machine. Selecting the tool in this form, this is purely just to pull through the feeds and speeds. So just using a flat end mill tool as a dummy end mill effectively to check over the feed rate and plunge rate. It's not actually possible to select a specific keyhole bit within our software for use with the keyhole gadget because it's not necessary, and we can't display it anyway. So all that we really need to do is just give visual reference to the result that you're going to see from as a bird's eye view, effectively, in top down. And there we go. We can see with the 2D solid view on, the area of the toolpath as the software sees it, and then also an outline vector created, which is placed on its own layer. So we can switch that on and off. If you make any mistakes or need to make any adjustments and run the Keyhole preview, the Keyhole gadget again, you can switch off and delete that Keyhole preview layer and reselect the underlying circle, so the circles remain unchanged, which is great. There we go, and have a look at the toolpath in the 3D view. We can see that it's actually created it as based on the array, so it's rastering from left to right and then back again, just completing each plunge, move to the end of the line, move back to the start point before retracting. So with that all set up, next thing we need to do is just to profile out our backing board. So go into the profile tool path, and we're going to be cutting again slightly past the full material thickness. Very similar settings to the boxes that we're creating. So just setting that up for the compression bit. Going 7.25, climb direction, check over the tabs, 50mm because it's a larger outline. Just manually place some of these. It's going to be sufficient to hold down. It's using 1mm tabs. Add a ramp, and we'll call this Perforated cutout, and click calculate. Again, it's going to tell us that we're cutting through the material, which we're aware of. And now we've got those, we just quickly preview those toolpaths. We can see exactly the order in which these are going to be machined. It is. It does seem like a fair few plunge and retracts, but it does actually rattle through them quite quickly. Especially if you set the clearance settings, obviously safe and appropriate for your machine, but to a sensible level. And there we go. That's what we can expect our backing board to look like once it's cut on the machine. And the next part that we're going to be looking at is actually making this more aesthetically pleasing. So we've got the functional aspect sorted, got our 2 sheets set up and the backing board and the caddy, as well as the additional boxes. But now we're going to look at some options to make this look a little bit better for displaying on your shop wall, within your garage in your home. So don't want it to look too plain. So let's take a look at that. The way that I'm going to do that is by adding a logo to the backing board and to the caddy. So you can actually make this relevant to what you're going to be using the backing for. So whether that be fishing gear, barbecue utensils, or as it was intended for the CNC shop. So whilst I was working on this, I didn't want to spend too much time, so I just sketched out some logo ideas. So we've got Tom's Fishing, John's Shop, Smith's Barbecue, just simple ideas. And then I ran these through Copilot to remove the lines and actually render these into something that would be suitable for vectorizing. So I've included those in the pack. You can bring those in, play around with them, change the names if you want. But for our part, we're actually going to look at using this in the Vectric labs. So I'm going to just use our existing Vectric logos. So for the caddy, I'm going to bring in the favicon outline. Going to place this on the front panel, make sure that we've got the right one because they look very similar. Let's place this over here. Make sure it's central and large enough. And I'm going to actually apply a V-carve toolpath to that. Don't want to go too deep because we've only got 9mm material. Going to use a 60° 1/4 inch V-bit and a clearance saw, an end mill 1/4 inch in the climb machining direction with an offset strategy. We'll call this logo V-carve. And click calculate. Close out that. Now we can actually switch on our other toolpaths. Just reapply this. And just to take a look over the layout, just check for any machining issues again and see if we're happy with the way that this looks. You can see the arrays of the smaller boxes at the top. That's the caddy bin cut. And the 100mm boxes. Now we can just take a look over how that logo is going to be expected to look at the machine. And I'm happy with that, so we can close out. Switch back over to the 2D view. And now that's actually the full layout done for the caddy, so we're going to switch over to the other sheet with our perforated background backboard toolpathing. And I'm going to bring in another Vectric logo, but this one is going to be in a different orientation. And it's got the strap line included as well. So, might be familiar with this. Just move that into position, make it a bit smaller. And that's just going to top off the header of this board nicely. So again, make sure we've got the vector selected. Set up our V-carving. Don't need to use clearance tools for this because it's a narrower set of vectors. I was wondering why the material looked dark then. It was facing the bottom, so the shadow was being cast. And we can just look over this, preview the toolpaths. Okay, so that's the backboard and the caddy completed and ready for machining. So it was one more bonus thing I was thinking for this modular storage solution. I wanted to create some inserts with the shadow foam. So we'll jump back into the software and see how we can set that up. Right, so to do that, I'm going to switch back over to the foam sheet. And what we need to do is create some outline vectors for the kind of items that we're going to be transporting in our caddy. So to do that, I took some photos with a ruler in frame. And this just gives a point of reference for physical real world scale. So what you'd need to do, take a photo of the item that you're looking to create an outline for to cut into foam. And a really good way, a simple method for making sure that this is 1-to-1 scale is if we draw out, so we've got 10mm here, if we draw a line between the 20 and 30 there, to make sure that's the right size. There we go. Then we can go into the Set Selected Object Size tool, and we know that in real life that would be 10mm. So if we enter 10, as it's now 29, we'll see underneath the proportion. So the scale of that is 33.84% of the existing dimension. So we know that if we switch over to the percentage setting for the scale in the set size object, and apply that to the photo itself, then everything will scale proportionally. So 3.84. So if we select the photo, and to the select size tool, switch over to percentage, and click apply. And there we go, that's just a really quick method for making sure that your photos are at 1:1 scale, so real world scale. After doing that, all you need to do is then manually trace to create the outline vectors. So I won't go through that here because we've all seen many live tracing examples, and we've got the tutorials available on our website, the vector trace, if you're interested and want to learn more about how to do that. So all I'm going to do now is just bring in the examples that I created for both a tool, so a CNC shop layout example. As we can see here, we've got the set square, 2 wrenches for the changing the collet, changing the tool in the collet rather, tool shape here, and this is actually for a tape measure. So that's one of them. The other one was for the barbecue. So I'll just bring that one in as well, and we can see the 2 different kinds of options. So we've got barbecue tongs and a beer bowl. So might be 2 important items that you'd want to be carrying around with you at all times at a family barbecue. So now we've got the outlines, we know that these are accurately dimensioned, so they'll sit on either side of our separated caddy. We just need to set up some simple profiles. So the beauty of using the shadow foam is that you don't actually have to pocket out the whole material. It's designed so that you just profile the outline, and then you can manually rip out the layers. So there's 5 layers in total of 10 mil. So if you make sure that your cut depths are at increments of that 10 mil, then you'll know that you're hitting a layer and you'll be able to get a flat surface. So I'll just quickly go through setting up the profiles for this. So again, we're using 50 mil material. We only want to cut through around 20 mil just to make sure that the item sits within the cutout. We're actually going to be using an 1/8 inch down cut end mill, and the reason that we use a down cut is because an up cut would fray the upper edge, which is something that we want to retain a crispness to, because otherwise it looks as if it's been ripped out. Going to clear all these passes, so we're going to complete this in a single pass with a fairly quick feed and plunge. Obviously you don't need tabs or ramps or leads, so we'll call this foam cutout and click calculate. One thing I should have mentioned then, sorry, is the direction, the cutting direction for the foam. So it's actually critical that you use the conventional direction. So in testing, the climb direction with the low density foam was just pulling and ripping out, dragging the material around. So the conventional just ensures that the material is pulled, it's effectively scooped by the flutes and pulled away instead of being pushed back into the material. So just make sure that we've got that selected, and there we go. So just to get a better representation of how that's going to look, I'm going to use a solid black colour, and we'll set the toolpath colour to Vectric yellow. And we're not going to be able to see exactly how it looks unless we apply a pocket toolpath, but we'll get an idea of the outline. And there we go. Last thing to do here really is to set up the cutout profile. This is very simple, just a full thickness, single pass with this longer 1/8 inch end mill that I'm using. They do supply specialist foam cutting tools which are additionally sharp for use with foam cutting. So that's one thing to bear in mind, and I'd recommend speaking to your chosen tool manufacturer for the recommended tools and feeds and speeds for your particular setup. And there we go, those are our 2 options. So yeah, if you are going to be cutting the backing board and caddy out yourself and have fun with it, you'll be able to decide what items you want to be carrying around, take a photo, scale it in the software, and you'll be able to create your own custom foam inserts. So with that, the tool pathing's all set up. Let's go to the machine and we'll get this cut out. And there we go, it's all complete and fixed to the wall. So I'm really happy with the way that this has turned out. It's really useful. And if you think it'd be useful for you and you'd like to have a go, then you can download the files from the UGM pack that are available on the store. So thanks very much for joining us on this project, and I hope you enjoy the rest of the UGM.